I'm Ashley Murphy, and I have a PhD in geology and environmental sciences. I knew as an undergraduate that I wanted to study geology of other planetary bodies, and I knew that I wanted to work for NASA. But I didn't see myself as somebody who was fit for graduate school. I don't come from a family of scholars. I'm a first generation student. I'm non-traditional. I didn't even have any friends that have gone to graduate school. So I kept this kind of NASA thing private as a dream. It was like a secret desire. And then when I was an undergrad at UTSA, I started telling people when they would ask, what do you want to do for your geology degree? A lot of people would assume petroleum because we're in Texas. But I started telling people I want to be a planetary geologist. And I was working with Dr. Alan Dutton at the time at UTSA. And when he found this out, he introduced me to Dr. Danielle Wyrick at Southwest Research Institute. And she invited me to come to the Institute, and we met. We had a nice lunch. I was in awe of the Institute. She kind of gave me a little pep talk about, finishing school and to get back in touch with her after I graduate with my undergraduate. And as luck would have it, or fate, whatever you want to call it, she came back the last year I was at UTSA, right before I graduated. She came back to teach an elective course on planetary geology. So I reconnected with her then, and she was hiring undergrads to come work in her lab at Southwest Research Institute. So I applied for the job, I got the job, and it was really through her mentorship that I decided to go to graduate school. So going to graduate school or picking a graduate school, I've noticed that there's two ways that students tend to do it. They either pick a school they want to go to, they apply, get accepted, and then they mingle with the faculty, find somebody they connect with, and they build a research project with that faculty member. And then there's the other way, which is the way I did it, which was you find an advisor doing research similar to what you're interested in. You reach out to that advisor if they have an opening, then they tell you that yes, they would like to work with you for your graduate experience. And then I applied to the school after I'd already found my advisor. So there's kind of two distinct ways to do it. And I think I did it the less common way of finding an advisor first and then applying to the school. I was, and I still am, really interested in all the big questions that NASA asks, like the are we alone in the universe and how did we get here? So I had this broad interest in planetary geology, but that's, you have to like pick a smaller field within that. So I was really obsessed with Europa at the time. Europa is an icy moon of Europa. Sorry, Europa is an icy moon of Jupiter. And I was very much interested in all the talk going around about if there's life on Europa, how would we detect it? What would a biosignature or a trace of life look like on Europa? So that kind of drug me more into the astrobiology realm. So if you think of a large umbrellas like planetary geology, and then astrobiology would be a small subsection of that. So when I went to graduate school, I was very interested in this idea of Europa, but I started sampling some local carbonate rocks in the area to just sort of learn the instrumentation that I was going to use and some of the techniques that I needed to know for the various research projects I was going to take on. And as I was studying these local carbonate rocks, I found that there were a ton of questions that just weren't published in the literature. There were things that weren't answered. And I kept going to my advisor and saying, like, I can't answer this question, or I don't answer that, I don't understand this thing because it's not published in the literature. And then she said, okay, this is how you do research. Like you fill that gap. If it hasn't been answered yet, you can study these rocks and fill that gap. So then I switched over because they were carbonate rocks. They were a much better analog to Mars. So I switched over to Mars, and I've been working on Mars now since. The main objective of my research was to characterize how biosignatures, so traces of life, whether they be an actual fossil or an element like carbon that's associated to life as we know it. So the main objective of the biggest project I had multiple projects, but the big project was to characterize how biosignatures are preserved in dolomized carbonate rock. So carbonate rock on Earth, it's a pretty simple sedimentary rock, but over time it can undergo a lot of alteration. And it wasn't really well characterized of how you would know if something was a trace of life or not, if you didn't have like a clear body fossil of a microbe or something within it. So the main objective of my research was to characterize how biosignatures are preserved in dolomized carbonate rock, and bigger picture of kind of how to detect and validate them, since the Mars 2020 mission and various other missions going to Mars. Mars has carbonate rock. So if there is a signature of life there, if life was ever present on Mars and is preserved in the rocks, we would also want to know how to detect it. Broader impacts of my research are relevant to geobiology, which is the interactions of life in the environment, and astrobiology, which is looking for life outside of Earth. So the particular types of rocks I looked at in the alteration phase they went to, these volumized carbonates, they don't preserve biosignatures very well, so we don't often find microbial fossil evidence in them, or sometimes it's hard to find even traces of carbon in them because they undergo such high temperatures. And this is all from what we know on Earth. So if it's difficult to find and validate life in old rocks on Earth, millions to billions of years old, if these same signatures are on another planet, such as Mars, which is pretty similar to Earth in its geologic history, from what we know, or what we assume, if it's as hard or harder to find them, any work that goes into that on Earth using these terrestrial analogs will benefit future studies. And, what instrumentation do we need on future missions? Favorite aspect of the graduate experience was actually two. One was a fun one and one was the most useful. The fun one was travel. So being a graduate student, you have money to go to exotic places and sample rocks. So I got to go to the Bahamas and Morocco for my graduate school experience. So I absolutely love that. That was the fun part. The most useful part was just learning how to be a science, like how to do science, how to plan your experiments or your project, how to carry it through and then write it up in a paper and get through the peer review process and publication. That was, you learn to do it once and it's kind of like rinse and repeat after that, but there's always challenges and failures mixed in and all sorts of things along the way. But it was really fun to just actually learn how to be a scientist. Challenging aspect of completing my PhD was definitely my first project, which was my first paper. And I think this was pretty normal, but just learning the research process, what data you need to collect, how to interpret it, who your target audience is, how to write it up in a paper, submitting it, it got rejected many times. And it felt like for me, like, oh, just failure after failure after failure. But once I figured out the process and like how to write a proper scientific paper, because I knew I believed in my science, I just had to figure out how to communicate that to the larger audiences. And once I got that down and it was published, after that, my second paper, it was extremely easy to write up and publish. But it was definitely the hardest part is the first year and maybe even the second year, because the first year in grad school, you're learning how to balance teaching duties, which usually a graduate student has. You have your own research and you have your own classes. So you have your own grades to keep up. And then the second year is pretty difficult because that's usually when you take your qualifying exams. So you're tested on your knowledge and you have to prove to your committee, here's everything I know, and here's the projects I'm going to do, and basically my plan to graduation. So I would say the first 2 years in general are the hardest. So one of the things I did that's even very helpful now was I started applying for grants really early. So I applied for a NASA early career grant, and I applied for internal funding for just like small travel grants. And that's very useful skills that build up when you're then writing, big 15-page grants for NASA after you get your PhD. The other thing I did is I would go to conferences every year and present my results. No matter how little of a result I had, I would just go present the results and learn how to, display my science, whether it's on a poster, when you're making figures or you're presenting it, and you're giving an oral presentation. All of these are important skills to build up on. And as time goes on, when you start meeting people at these conferences and they're getting interested in your research, you start getting invited to do seminars. So you'll get invited to go to different universities and give a seminar. So grants, talks and presentations at posters and seminars at other universities. My graduate experience prepared me excellent for my current position. I'm currently on the SHERLOC instrument team for the Mars 2020 rover, and it uses what's a Raman spectrometer. So this is a vibrational spectrometry technique. So basically you have a sample, which would be a rock in this case. A laser, I always say I zap rocks with lasers as a joke, but a laser would interrogate the sample and the molecules in that sample vibrate, reflects the laser light back, and then there's a detector that picks it up. So we get a little signal that kind of looks like squiggly lines, but that signal is like a fingerprint for whatever molecules are making up the rock. So minerals, organics, anything that's in there, we can tell based on where these peaks are. So I learned this type of Raman spectroscopy for my graduate degree, and I was also studying rocks that are similar to the rocks on Mars, which are carbonate rocks. So everything I did worked out really well for my current position. Undergraduate asked me if graduate school was worth it. I would say yes, for my purposes. Getting a PhD was worth it. I wanted to work on a NASA mission, or I wanted to work with NASA on these big ideas. I basically wanted to write my own proposals, do my own original research, and pick who I wanted to work with. So if you're kind of a self-disciplined person and you know that like you want to be in control, you want to be the principal investigator or a PI of the work you're doing. So pick what you're studying and pick who you're working with. Definitely a PhD is how you do that. If you know that early on, that's great. There's also just getting a master's degree. You can go from bachelor's to master's to PhD, or do what I did, which was just a bachelor's straight to the PhD, because I knew ultimately I wanted a PhD. But a lot of students start with a master's to just kind of see if they like the idea of research, especially if it feels like a foreign topic to you and you're not really sure. Starting with a master's degree might be a good way to go. I'm going to repeat what Dr. Danielle Wyrick from Southwest Research Institute told me, and I'm going to paraphrase a little bit, but picking an advisor is kind of like picking a partner. It's sort of like a long-term relationship. Graduate schools for a master's, like a minimum of 2 years. For a PhD, usually can be around 4, sometimes as long as 6 years. So the person you're working with, your advisor, you're going to be spending a lot of time with that person, and you really want to have a good relationship with that person. And then it kind of extends to the other professors and the community and the university you're at. These are kind of like your in-laws and where you're living. So all of these things matter because graduate school is going to take a pretty big chunk of your life. So I would say definitely find an advisor that you're comfortable with and you feel like you can work with.